Thanks for watching this demonstration of the Mettler-Toledo G10S and G20S compact titrators. Our goals are to provide a familiarization with the basics of the functions, give an overview of the one-click user interface, and to point out some of the benefits that make these units ideal for routine applications and simple operation. The first thing we'll do is get to know the layout of the titrator's terminal. The power button is located here on the front of the instrument. Pressing the Info button accesses interactive online help for the content of the dialog that is currently on the screen. The Home button returns the user to the home screen from any menu position, even while tasks are running, and the Reset button ends any current tasks. This is the home screen. It is the shortcut area where all one-click tasks are set up. The units allow up to 30 user-specific screens. The G10S allows up to 4 icons on its home screen. The G20S uses up to 12. The status bar contains the current menu item, the date, time, and current instrument status in the Tasks section. The Start button is for a quick start for a defined standard measurement of the instrument. User Data is for information about the currently logged-in user, and the Logout button is to directly log out the current user. There are 5 menu buttons in the column on the left. The Methods menu is where methods for calibration, titrant standardization, analyses, etc. are created, edited, and deleted. The Series Templates menu is where sample series of up to 120 samples are created for any available method on the titrator. The Results menu provides detailed information about results, sample information, and statistics for print or export on the most currently run individual or sample series. The Setup menu is where system settings are customized within an individual lab's requirements. The first submenu under Setup is Chemicals. Titrants, calibration standards, auxiliary reagents, and the like are managed here. User Settings is where user-specific settings such as language, setup of shortcuts on the home screen, and even the screen color are defined. Values. Blank values and other auxiliary values are managed here. Blank values are used when subtracting solvent blanks, and auxiliary values are used to pull other external values to be used in a calculation, such as with a back titration. The Hardware menu contains settings for the various hardware resources used by the titrator, such as electrodes, pumps, and printers. The Global Settings menu is where system settings, user management, and analysis and resource behaviors are managed. The Maintenance and Service section is where methods may be imported or exported, where a factory reset can be performed, and where the firmware can be updated. We can go back to the home screen by selecting Back. Finally, the Manual menu is where manual control of various resources is done, such as taking a quick pH measurement or activating the stir. There are only a few steps to getting the compact titrator ready to run samples. Everything that's needed to get started with an acid-base titration is included in the box. All that's needed is titrant. In this demonstration, we'll perform an acid-base titration using 0.1 normal sodium hydroxide as the titrant. However, with the appropriate electrode and reagents, these units can perform redox, argentometric, and photometric titrations, as well as ion-specific measurements. First, we connect the power supply to the back of the titrator and plug it into the wall socket. Then, power it on, and log in as the system administrator. The titration stand is where the sample cups are attached, and it is fixed to the titrator with a screw. Available stirrers are the built-in magnetic stir and the propeller stir, which is installed by placing it in the titration head and attaching the propeller stirring rod from the bottom. The titration head rotates to use either stir. The propeller stir is plugged into the stir pump input on the back of the unit. A DGI 115 combination pH electrode comes with the unit. The electrode cable is attached to the electrode on one end, and on the other it's connected to the back of the titrator at the sensor port. On connection, an identification message will pop up, confirming the new addition. This plug-and-play feature of the compact titrators helps reduce errors by ensuring correct titrants and electrodes are in place for the current analysis. After putting a few milliliters of 3 molar potassium chloride in the electrode holder, the electrode and holder can be kept on the titration stand for now. If using a printer, it should be connected to power and then to USB 1 or USB 2 on the back of the titrator. To assemble the burette, the dispensing tube is attached to the right side of the stopcock valve, and the burette tip is placed in the burette holder. The suction tube is fastened to the left connection on the burette head. The other end is pushed into the titrant bottle, the red tubing pushed onto the fitting. The burette can be stored on the burette stand. Sodium hydroxide titrant must be protected from atmospheric carbon dioxide, so the drying tube is filled with a CO2 scrubber and fitted on the burette stand with the drying tube holder. The burette body houses the plug-and-play RFID. Burette volume, titrant concentration, and the serial number of the burette are kept here. So this feature prevents the accidental use of the wrong reagents. Lastly, slide the burette on the titrator and place the dispensing tube in the titration head. The titrator recognizes a new burette and gives instructions. Assign the titrant by selecting Create. Selecting the name field and selecting Proposal lets us select the titrant, in this case NaOH. Selecting OK brings us to the previous screen, and the default titrant concentration of 0.1 moles per liter is correct. Finally, the burette volume needs to be set at 20 milliliters. Selecting Save writes this to the burette's RFID chip, so next time the burette is used on any plug-and-play titrator, it is automatically identified. Finally, the burette is filled by entering the Manual Functions menu, selecting Burette, finding the 0.1 normal sodium hydroxide, which will be identified with a PNP. 3 cycles will completely charge the burette and tubing. A cup is placed on the titration head, and we start, and the burette starts filling with titrant. The titrator assembly is now complete, and we're ready to get started. A method is a set of instructions the titrator follows in order to accomplish its various titrations. The compact titrator's standard methods include the following types. Endpoint titrations. These are primarily used when titrating to a pH endpoint. Equivalence point titrations are used for non-pH titrations, such as salt content with silver nitrate or redox titrations, but can be used for pH titrations as well. Titer methods are used for standardizing titrant with a standard substance. Calibration methods are used for sensor calibration, usually used to calibrate pH sensors for endpoint titrations, but they are also used to calibrate ion-specific electrodes. The pH sensor test method is used to check the slope, 0 point, and drift of a pH sensor, like an electrode health check. Measure methods are used for controlled transfer of a sensor measuring value, such as a series of pH measurements. Blank methods are used to account for a solvent blank in our titration. Running this method stores the result as a blank value. This stored value is in turn used in calculation of the sample's titration method, subtracting it from the result. Lastly, the learn titration is used, for example, with an unknown new sample to determine the best parameters for carrying out an EQP titration. Titer determinations. Most users purchase a pre-standardized titrant and initially skip this step. In cases where labs make up their own titrant or would like to use a titrant that has been around for a while, the titrant can be standardized with the titer determination method. We start by selecting the Method menu selection and starting a new method. The 2 selections are Standard and Mettler method template. Standard templates give us a blank slate with which we create our method. The Mettler method template chooses from a list of ready-to-use common titrations whose method parameters have already been set and can be edited. Looking under the Mettler method template, titer of 0.1 normal sodium hydroxide is one of the methods, so this one is selected. This is the method function list for the method. Although this method has been customized for sodium hydroxide standardization, some of the method functions may be customized to make it specific to the lab or the user. Title. Methods are given a unique ID. The title may be changed if desired. Sample. Titer. The primary standard used to standardize sodium hydroxide is potassium hydrogen phthalate, and the Mettler method specifies 80 to 120 milligrams. Titration stand. The standard setting is a manual stand, and this is where you tell the unit if you are using a Rondolino automated stand. Rondolino automates analysis of up to 9 samples, dip rinsing in between samples, and conditioning the electrode when the series is complete. Stir. You define for how long and at what speed the sample's stirred. This one's set to stir for a minute at 35% speed. Titration. This is where all the parameters of the actual titration are defined, such as rate of titrant addition, termination criteria, etc. Since this is a Mettler method, the parameters have already been optimized. Verify that the titrant selected is the plug-and-play 0.1 normal sodium hydroxide, and that the plug-and-play DGI 115 is selected. The calculation functions are where the raw results, such as final volume, are converted. The default on this method is the standard titer calculation, so there's no need to change it in this case. This function is also where you would choose to run statistics, such as average and standard deviation. End of sample signifies the end of the sample loop. So if this method is run with, say, 3 samples, the titrator performs all functions inside the loop on each of the 3 samples before ending the run. The titer function takes the mean of the 3 results and assigns it to the titrant so it is used globally. This second calculation function is set up to take the mean of the results. Calculations are freely choosable, and these have more meaning in sample titration methods. The record function is only used when you're using a printer. It can be edited with a variety of data. However, right now we'll keep the settings to have a basic summary printout. We're now ready to save the method. Selecting Start allows us to assign it as a one-click icon to the home screen if desired. We're now ready to add samples. The titrator asks how many KHP samples will be run, and sample weights can be entered by selecting the Samples button. Connecting a Mettler-Toledo balance enables automatic transfer of sample weights. Move the electrode over to the titration head, and uncover the electrode filling cap. Pressing OK begins the first analysis. The titrator will run its first analysis and notify when it's ready for the next sample. After the 3 samples, the titrator outputs its results to the screen and the printer. With the titrant now standardized, sample analysis can begin. Setting up a sample analysis method has many of the same steps and method functions as the titer determination. In this demonstration, we will determine the acetic acid content of a vinegar sample. Start by selecting the Method menu selection and starting a new method. Under Mettler method templates is acetic acid in vinegar. This method's parameters have similarly been optimized for this titration, so only a few customizations need to be made. The method ID is customized in the title function. In the titration function, once again ensure that the method is using both the plug-and-play burette and the DGI 115 sensor. In the calculation function, a selection of pre-configured calculations is available. In this case, we'll change to grams per 100 grams by selecting Result Proposals and locating it in the list of calculations. We can now save and start our method. Samples will again be run in triplicate. About 1 gram of the sample is weighed out into a titration cup. The weight is transferred. About 40 to 50 milliliters DI water is added. It's put on the titration head, and the analysis is started. Once again, an overview of the sample results as well as a printout are available when the samples are done. This demonstration covered a basic acid-base application on the compact titrators and hopefully showcased its ease of use and flexibility. Other applications include salt content of food products, vitamin C content, iodine and peroxide number of edible oils, TAN and TBN of petroproducts, copper and nickel of plating baths, water hardness. Greater detail on their capabilities can be found in the instruments brochure, which can be found on mt.com/titration. Let's take a quick recap of the differences between the G10S and the G20S. The G10S has a maximum of 10 method functions. A G20S can have 12. A G10S has memory for 5 methods. A G20S can hold up to 100. Up to 12 icons can be placed on the G20S's home screen versus 4 on the G10S. The use of LabX Express titration software, a second drive, and a barcode reader are only possible on the G20S. Finally, the compact titrators are part of a much larger titration product offering from Mettler-Toledo. So if your lab is in need of more capabilities such as Carl Fisher analysis, greater automation needs or higher sample throughput, more than one burette and electrode available for titration, or more method functions, you can find information about our Titration Excellence line at www.mt.com/titration, where you can also notify us to have someone contact you.